So let's do another problem. This is 14.34 in your book. I'm going to read the problem out. A 32.2 pound object is dropped from a 100-foot building. Determine the velocity and kinetic energy at A, 50 feet level, and B, 25 feet level above the ground. Okay, so it's a straightforward problem. There's a building that is 100 foot tall. A ball is dropped from here, so we're asked to find the kinetic energy here at KE1 and here KE2. So KE1 is 50 feet above the ground, and this is 25 feet above the ground. Let me say here from ground. So to find the kinetic energy, we need to find velocity, but the velocity is not given directly, it's given indirectly here. So we know in your previous chapter 10, I believe, we did these when we're doing these kind of problems involving velocities, initial final velocities, acceleration, and all that. We have seen these kind of problems. The only thing is, this is one step further, where after finding velocity, we also need to find the kinetic energy. Now, let's write down the data. So initial velocity is 0, v1, right? So v1, we don't know, we need to find, and v2 is also we don't know. So this is v2 is the velocity at this point, v1 here. What else do we know? We know s1, s2. S1 is the distance traveled here, so the distance traveled up to here is 50 feet, right? 50 feet. S2 is 75 feet, because from here to here is 75, because this is 25, right? Okay, so we'll use the formula that we know. Of course, acceleration is acceleration due to gravity. Okay. We'll use the formula which connects these three things. So we know v squared minus u squared is 2as. So in this case it is v1 square, right? S1. So v1 square minus 0 is equal to 2 times 32.2 times S1 is 50, right? So v1, when you calculate, let's see what you get. You get 56.75 feet per second. Okay, the corresponding kinetic energy KE1 is equal to half v1 square, so half. So do we know the mass of the ball? Yes, it was given as 32. So in the problem it was given as, I believe, 32.2. let me check again. Yeah, 32.2 pound, right? So that's actually the weight of the ball. That's actually the weight of the ball. That means we need to convert it to mass. So 32.2 divided by the g value, 32.2, v1 square is 56.75 square. So basically you get KE1 as 1610 foot-pound, foot. This is KE1. Okay, so at this stage, that is the kinetic energy of the ball. Let's look at this here. Let's look at the KE2 here. It's the same process. v square minus u square is 2as. Here we'll say v2 as 2. So v2 square minus 0 is 2. 32.2 times s2 is 75 feet. So v2 is equal to 69.5 feet per second. Okay, and KE2 would be half m v square v2 square. Half m is the same, 32.2 is the weight, divided by g, 32.2. v2 69.5 square is the v2. So you get 2415 foot-pound. Okay.